So let's go ahead and talk about the types of reactions. We've been balancing chemical equations, and we will continue to balance chemical equations. But we're going to talk about the types of reactions today. You just saw that short video on them, but that was a lot to take in. So, for reactions, really quick though, what happens in a chemical reaction? Well, atoms are not created or destroyed. In chemical reactions, atoms are rearranged. So that understanding that they're going to be rearranged, they're moving all around, helps us to understand that they can move around in different ways. It's kind of like a dance. There's lots of different kinds of dances out there where people move around in different kinds of ways. Chemical reactions or chemicals are being rearranged. So let's look at the first kind. The first kind is called a synthesis. Or, an easier word is combination. So, when you look at those words, what does that mean? If I combine something, what am I doing? Putting two things together, right? So putting two or more things together. Let's kind of look at that example that she gave. She said we would have A plus B makes or produces AB. So let's digest that, take it down a little bit. We have a single element. Actually, these are both single elements. And they come together to make a compound. So you begin with two smaller things. Smaller things, we get one more complex. So that's synthesis or combination. And you're going to have to look at equations and identify what they are. So when you look at them and you're looking for combination or synthesis, you're going to say, all right, what do I start with? I start with single elements or two smaller things, and they combine together. They are put together to make one bigger thing. All right. Thumbs up if that makes sense. Is that one clear? All right, good. The second one that we need to talk about is decomposition. What does it mean to decompose? To break down, right? Like leaves in the forest right now are decomposing. They're breaking down, they're becoming dirt. So decomposition is to break down, to fall apart. Okay, so let's look at what that might look like. And this is really the reverse of synthesis or combination. So we would have AB becoming or producing A plus B. So you can see that's exactly the opposite. In decomposition, we start with a compound that is more complex, and we go to single elements. Or two smaller things. Alright, so you might note that. You might put a little So these two are opposites. All right. All right, so let's look at the third kind. Third kind is called single replacement. Single replacement. What does to replace something mean? To switch it, okay? That's a good way to look at it. If you replace something, you usually put a new one in its place. Like if you replace your phone, you got a new phone, you put it in its place. What does single mean? Just one, right? So if we look at what you just said, single replacement is just one switches. Just one switches. So in a single replacement reaction, we would have something like A plus BC gives me B plus AC. So what happened? Just one switched. So we had a single element. Notice you start with a single element and a compound. And you result, or you produce, a different single element. Different single element. And a new compound. Okay. Alright. So we're going to use an analogy when we get to our Quizlet in a second, but let's just continue discussing them and then we'll go back to that. Give me a thumbs up if that makes sense. Do all three of those make total sense to you so far? Cool. Alright. Alright, number 4 is double replacement. So this one follows the same kind of lines as single replacement. We're going to use what you said before. Same words. You said replacement means switch. And that's a pretty good word. That's a terrible W, but double replacement. Replacement means switch. What's double mean? 2, right? So the definition for double replacement is 2 switch. Alright, so let's look at that. In a 2 switch, in a double replacement, we're going to have like AB plus CD gives me or produces AD plus CB. So everybody got a new partner. Okay, so what you start with is you actually start with 2 compounds. And you end with 2 different compounds. Right? Okay, and the last one that I want to just kind of draw out is a combustion reaction. What is combustion? Well, like a combustion engine, what happens inside of it? It explodes. So a combustion is fire or explosion? You don't have to answer this, but I'm sure that some of you rather enjoy bonfires or fireworks or anything like that. Combustion is at the heart of all of those events. So when we look at a combustion reaction, these are the ones, this is the only one that has a really specific ending. Every single time there's a combustion reaction, it produces water and carbon dioxide every single time. Now that's kind of weird because we usually would use water to put out a fire, but from combustion, water and carbon dioxide are always produced. So if we know that, what does it have to start with? We have to have oxygen. That's right. If you guys have burned a candle, right? Have you ever put the lid on it to turn it off to make it stop burning? Probably. And that's because you reduce the amount of oxygen that it has. So we need oxygen. So what's left? If we know we have oxygen, we gotta have hydrogen. That's right. And carbon, yeah. We gotta have, and this thing is called a hydrocarbon. That is kind of beyond the scope of what we need, but we'll label it just for our purposes. So that hydro means hydrogen, and carbon, obviously carbon, okay? But you have to have a hydrocarbon. These subscripts can be anything that makes a compound. Oxygen is always going to be O2 because it's diatomic. It has to have a buddy, right? But then over here, your coefficients might all change. So you still have to count and think about it, but the coefficients would change for all of those. All right. Does that make sense? Thumbs up if that makes sense. Every time you have a combustion, you're going to have water and carbon dioxide. Sort of sideways? Okay. All right, let's go back and look at all of these together. We said at the beginning that types of reactions are really atoms being rearranged, kind of like dancing around. You can think of these kind of like going to prom, okay? Kind of like going to a dance. In a synthesis or combination, we have two single people and they make a couple. All right? Two single people make a couple. Decomposition, we've got a couple, uh-oh, they break up. That's sad, but happens. Single replacement and double replacement are kind of the interesting ones. Look at what happens to single replacement. We have a single and a couple, and the single takes one's place. Have you ever seen that happen? No, never, not here, right? But the single takes one's place. So single replacement, we have a single and a couple. The single took one of their places. Double replacement is super interesting. We have two couples that mix up partners, huh? Yeah. All right, so double replacement, you're gonna double switch, two switches, all right? And then combustion always ends the same. You guys know couples like that, they always end the same. Either, in this case, a fire, but, so it's always hydrocarbons and oxygen always end up the same, water and carbon dioxide. So it's kind of an interesting analogy, but it works to help you understand what you're looking at there. So remember, synthesis and combination are opposite, or synthesis, combination is opposite of decomposition. Okay. Single replacement and double replacement are pretty similar. Single is just one switch, double is two switches. Combination always ends in water and carbon dioxide.